Hello everyone. In this particular video, we are going to discuss and execute the code that we have discussed in lecture 2.3. Okay. So here is the slides that we have discussed in the lecture 2.3. So if you see here what we have discussed about the DDL command or DDL language here. So as you all know that SQL we use to retrieve a data from a database, right? And in that we store data in a tabular format, that is a structured format here. So if I have this particular table here, we are storing a data in this particular format like this, okay, tabular format. So for example, I have a table name, let's say for example student, okay, and this table will have columns and rows. For example, this is roll number, this is basically a name column, for example this is age, and let's say this is department here. Okay, now we are storing a data in tabular format and there will be a rows corresponding to this particular columns in the table, right? So in DBMS, what we call these columns as attributes. Okay, so whenever I say attribute, it means basically a column name of this particular student table. Okay, so whenever I say student relation or student table, both are the same thing. You can consider here also attribute and column name. Okay, also when I say tuples and the rows are basically the same thing here. Okay, so you can say this is basically a rows, or we can say tuples. These are the attributes, or we can say a column name. And here student is basically a relation, or we can say one table name here in the case of database here, right? So this is how we store a data in tabular format in relational database. Okay, now let's see what are the different things we have. When we want to create or when we want to define any particular table, we should know the attribute name. Also, if you see what data it can take, okay, so that is basically a data type. So we'll discuss about a data type, okay, and then we know this attribute, we know what are the different data type, and we know that what data this particular column can take. So accordingly we can select a data type. Also a constraint part. Okay, so we'll discuss about the constraint also here. Constraint means what? I want to restrict this particular column for taking some particular values. So that is what a constraint is. Simple as that. Okay, so this is regarding the two things, data types and constraint with respect to an attribute here. Okay, for this particular table. So let's try to discuss how we can create this table, what are the different data types and constraints in SQL. Okay, so in the lecture we have discussed this particular thing in slides 8.12. Here you can see different domain types in SQL, or we can say data type in SQL here, right? So we have different data types, char n, varchar n. So these two are used for a string data type or string values here, like for example text value. Integer data type used for a integer value. Similarly, small int. Numeric is used for a decimal value. For example, when I say numeric 3,1, it means that I can insert a value having total 3 digits, but after decimal point only 1 digit are allowed. Okay, so here you can see a fixed point number with user specified precision of p digits in total with d digits to the right of decimal point. So when I say numeric 3,1, so I can insert 44.5. I can also insert 4.5, but I cannot insert 4.50 because it will violate this particular constraint, that is p comma d. Similarly, I cannot insert 4.5 because after decimal point it should be a 1 digit here, but in total we should have 3 digits, but here we have 4 digits in total. Here also after decimal point we should have only 1 digit, but here we have 2 digits. That's why we cannot insert these two values when we say numeric 3,1. We can insert 44.5, we can insert 4.5 as well. Okay, we cannot even insert 4.50 because after decimal point here we have 2 digits here. Okay, now we have real and double precision, and then we have float data type. So we have discussed this thing in detail in the next tutorial, so you can watch that tutorial based on data types and constraints. Okay, so I have executed this in SQL and show you how each different data types works and what are the constraints in SQL and how to create a table by using those two things. So I have discussed that in the next video. So please do watch that video after this particular video. Okay. Now this is about the data types here. Now here you can see a schema diagram for university database. So in the entire week 2 and week 3, when we are going to discuss about the SQL part, we are going to deal with the university database. And we already shared the data set with you. You can simply load this data set into your PG admin. So if you have not done that, please do it. Okay. So this is the schema given to us. Now how to read this particular schema? When you see this particular thing here, that is basically a table or relation we can say. So here you can see a student here. Student is a relation and having attribute ID, name, department name and total credit here. Similarly, text is basically a relation having the attribute ID, course ID, section ID, semester, year and grade. Okay, and these two tables are linked to each other by what? Course ID. So here you can see a arrow here. Now what this particular arrow indicates, we are going to discuss that thing in the week 4, that is ER diagram part. As of now, just understand that this is basically one relation, that is a section having these attributes in the database. Okay, and these are linked to other tables by this particular attribute. So here you can see the arrow part. Okay, now this is what we are going to discuss in this particular video, how to create a table. So when I say create table, because if you see the schema diagram here, if I want to create a table for student or for text, how to do that? Okay, so let's discuss that first now. So here you can see a syntax for creating a table. So first you have to mention create table. With R is what? Name of that particular relation. For example, if I want to create a student, so I will specify this as student. Create table student here. Okay. Then we have A1, D1. Now what is this A1, D1 here? A1 is basically attribute name and D is basically a data type of that particular attribute. Okay. We'll execute this particular create table and let's discuss how we can create a table in SQL. Okay. And here you can see a instructor, a table here, right? This one. So we are going to create an instructor table by using this particular code. So let's discuss this code here. So create table. Then we have to specify the table name, that is instructor, and then we have to specify the attribute along with its data types. ID is attribute, data type is char5, name, data type is varchar, department name is attribute name, varchar is basically data type, salary is attribute name, and numeric 8,2 is a data type. If we observe here, we don't have any constraint. We are simply creating one table here by a name instructor having these few columns, ID, then we have name, then we have department name, and we have one more thing, that is salary. So we are simply creating one table having those 4 columns. Let's try to execute this thing in SQL now. Okay. Now here you can see our PG admin. Now let's try to create one table here. Okay. So before creating a table, let's create a database. So simply right click on database, create database, and then just give any name. So I am giving this week 2. Click on save. So here you can see week 2 database has been created. Now right click and go to query tool here. And this is the editor where we are going to type our SQL code and then we can execute that. Okay. So if you observe here, you can see this SQL code for creating a table instructor. Let's copy this and let's try to execute in the PG admin. Okay. So here you can see I have copied that particular code here. And now if I just select this and run this particular code, so here you can see table has been created successfully. Now to verify whether table has been created successfully or not, what we can do, we can simply type select star from and that particular table name. Say for example instructor. So what we are going to do here, the select command will give a data from this particular table, that is instructor. Select star. Star means what? All the attribute here. Okay. So we'll discuss that thing in detail. So select star from which table I want to get a data. That is from instructor table, right? So select star from instructor. So if I select this and if I run this, So here you can see I have created a table ID, name, department name, salary. But as of now, I don't have any rows here, right? So this is how we can create a table in SQL. Okay. So simply create table, mention the table name, attribute name along with its data type. Okay. So these are the few things required for creation of a table. Okay. Now here you can see, so we have different types of constraints. So here you can see not null. I have unique constraint as well. We have check constraint as well. So we have discussed this thing in the tutorial. You can watch that. Okay. So not null. Also primary key. When I say primary key and any attribute, it means that that particular attribute or set of attribute will have not null plus unique constraint. Okay. Not null plus unique constraint. So as name suggests, not null. It means that for that particular column, there should be some value. It should not be a null. Also, all the values in that particular column must be unique. That is what a primary key is. And here we have foreign key, some attribute references to a particular table here, okay, or a relation we can say. So in the previous slide, what we have discussed, this particular thing, we have created table instructor, okay. But if you go back and see a schema about this instructor here, see ID is a primary key here, okay, and department name is what? Department name is taking a reference from this particular department table with this column department underscore name. So this is what a foreign key is. Okay. Now if I want to create this particular table instructor satisfying this constraint as primary key and this as foreign key, how to do that? So here you can see the code for this. So create table instructor. So here you can see ID char 5 name varchar, but here we have specified the not null constraint, department name char, salary numeric data type, then we have primary key and ID. So in the bracket we have mentioned ID here because we want to make this particular attribute or we can say column as my primary key. And what is foreign key? Foreign key is basically this department name from this table referencing to what? So we are taking a reference from this department table here. Okay. Okay. It means that whatever the values are present in this department table, in this department underscore name column, for that particular values only we can insert a department name here. Okay. We'll discuss how it works. Okay. For this particular department underscore name only, we can insert a department underscore name in this particular instructor table because we are taking a reference from a department table here. Okay. That is what a foreign key constraint is. Now we have already created this particular table. Now let's try to create this table now using this constraint. Okay, let's see what happens. So here you can see I have pasted the code here. Now I am selecting and now I am going to run this code. Now see what happens. Instructor already exists because we already created a table by this particular name. So we cannot create a table with the same name again in the same database. Okay. So we need to drop this particular table. How to do that? Simply drop command. Drop table, then specify the table name. Then specify the table name. Instructor, right? Just simply select this drop table instructor. So you have successfully dropped the table now from the database. Now we can create a new table here. Okay. Now let's try to run this particular code. See what happens. So here you can see relation department does not exist, right? So we cannot create this particular table because this department name is going to take reference from this particular department table. So first we need to create this department table and then we can create an instructor table because it is taking reference from department table. So first we need to create a department table now and then we can create the instructor table. Now let's go back 2 slides and see what is department table here. Okay. Now if you observe here, this department table is having 3 attributes: department underscore name, building and budget. And if you see this underline, so whenever you see any attribute that is underlined, it means that this particular attribute is what? Primary key. Okay. So whenever in the schema, if you see attribute that is underlined, that is basically a primary key. It means that it is having not null plus unique constraint here. Okay, remember this important point. Now first we'll try to create department table and then we are going to create the instructor table here. Okay, so let's do that. Let's create a department table first. So here I'm going to create a department table. So create table department, then we have department underscore name as my attribute, then we have its data type, for example varchar 20. Okay, now if I want to make this department underscore name as my primary key, so there are two things. Either you can specify like this primary key, then in bracket id after creation of this attribute name, or along with this data type also you can simply mention primary a key here. That's it. It means that this particular department underscore name is my primary key for this particular table department. Okay, then we have building. Again we can put varchar here, and then we have budget. Okay, budget, let's say int integer data type. Now that's it. Let's try to select this and execute this particular command. So here you can see we have successfully created a table department. Now I'm going to select this particular code and let's see what happens now. So here you can see create table successfully. Now if I just select star from instructor, okay, so here you can see we have successfully created a table instructor, and now you can see PK symbol here. So previously when we create a table instructor here for this scenario, if you observe, this PK was not there. PK means primary key. Okay, but now here we can say we have specified that ID is basically my primary key and department underscore name is basically my department here. Okay, so this is how we can create a table in SQL. Okay, now here you can see in slide 8.18 we have other tables as well. For example, we have a student table, we have a course table, we have a text table. For creation of student table, we want department, we already created. For creation of course table, we want a department name because taking reference from department table, we already created. And here if you see here, create table text. Now for this particular table, we want section table here. So first we need to create a section table and then we can create a text table here. But as of now, what we have done, we have created the department table, we have created instructor table. Now we can create a student table as well as the course table. Okay. Now let's try to create the student and course a table here. Okay. So I'm going to simply copy paste the code in the PG admin now for student and for the course. Now here I am copy pasting the code from the slides here, okay, for the course as well as for student. So I'm selecting a student code first. I'm going to execute this. Successfully created student table. Now for course table here also same thing. Yeah. So we have successfully created student as well as course table here, okay. Now if you observe, we have created student, we have created course. Now what you need to do, first create a section table and then try to create the text table. So this is a homework task for you. You need to create a section table. Also for creation of section table, what you need to do, let's look at that, because if you observe building and room number, it's taking reference from classroom. It means that first you need to create a classroom table, then create a section table. And after creating section table, you need to create the text table. Okay, this is a homework task for you, and please try to do that and see whether you are able to create this text table or not. Okay, so this is the homework task for you. Now then we have discussed few other commands in SQL. That is, for example, insert. So as of now we have simply created a table. We have not inserted the value in that particular table. Now if I want to insert a value in the instructor, let's see whether I can do that or not. Okay, so I'm going to simply copy paste this particular thing. Let's see if I can simply insert this particular values in the table or not. Okay, I'm copy pasting that insert thing here. So you can see insert into. So this is basically a syntax for inserting a row into a particular table. insert into, we have instructor, then we have values and the corresponding values for the each attribute here. Okay, so if I simply select this, click on run, what is happening here? Here you can see instructor voids foreign key constraint because this department name is taking reference from department table. It means that what I said earlier, we need to first add the row in the department for that particular department underscore name, and then we can add the corresponding data in the instructor table. Okay, so let's try to insert a row into a department table first. Insert into department, then we have values, and then so department name, for example, biology here. Building, I will give any name, say for example XYZ, and let's say budget is basically what, 90,000 for example. So first I'm going to insert this particular thing. Now here you can say insert O comma 1, so successfully inserted in the department table. If you want to check, here you can see a command select star from department. Okay, now just simply execute this particular code. So you can see a department table here having this particular entry. Now we have successfully inserted the department biology in the department table. Now let's try to insert the value corresponding to department biology in the instructor table here. Now let's try to execute this particular code and see whether we are able to execute this successfully or not. So here you can see we have inserted successfully. Now if you select instructor table, select star from instructor. Now here you can see that particular row here, right? So this is how we can add the rows into a table. So here you can see insert command, we already discussed this. So if you observe, we need to add the values in the same order in which the columns are there. But if you want to add for few specific column, in that case there is a different syntax for that. Okay, so we'll discuss that in the next video. Okay, then we have delete command. We can simply remove all the rows. So here for example tuples is basically a rows. We can remove all the tuples or rows from a student relation by using this particular query, delete from student. So it means that we are going to delete all the rows from a student table. If you want to delete specific rows from the student table, for example, if I want to delete a data of a student whose roll number is 21F1, in that case, I can simply put a condition that delete from student where roll number is 21F1. So we are going to discuss that in the next video. Then we have drop table. We already discussed the drop table command. We have dropped the instructor table, right? And then we have alter command, that is DDL command. So we'll discuss that thing in the next video. Okay. Now, next we have DML command. Okay, that is data manipulation language. So here you can see a basic query structure here. So as of now we have discussed various DDL command. Now here we are discussing a select query here. Okay, so select, and if you see we have a table and we have number of columns. But if I want specific columns, then you have to specify which column you want. For example, select A1, A2 till AN. It represents the attribute, or we can say column, from a particular relation R. Then from which table I want to get the columns, right? That is what we need to specify here. And where P is what? Predicate. Predicate means what? Condition here. Based on this particular condition, I am going to get my data. Okay. So we are going to discuss that thing. So basic SQL query is what? Select from where. So I need to select this particular column from this particular table where my condition is this one. This is what a basic SQL query is. Okay. Now here you can see select clause, that is a select command here. Okay. So if I want to find the name of all the instructors, so what I can do, select name from instructor. That's it, right? So you don't need to put comma here. Simply select name from instructor. And here you can see this name is a case insensitive. You can mention name, doesn't matter because it is case insensitive. Okay. So in this way, this particular code will give me name of all the instructors from the instructor table here. Okay. Now select clause. SQL allows duplicate in relation as well as in query result. For example, if I have multiple instructor by the same name, so if I do that, I will get the name of those instructor. But if I want to find out a distinct, or we can say unique instructor name, for that purpose I can use a keyword a distinct here. Okay, for example, find the department names of all instructors and remove duplicate. So in that scenario I can use this distinct keyword, so it will ensure that the duplicates are not present in the department underscore name. Okay, so this is what we are going to get from the instructor table. Now let's try to execute this two code in the PG admin now. But before that, here you can see the keyword all specifies that duplicate should not be removed. So even if you didn't specify this all, so by default it is giving us a duplicate value as well. Okay, so let's discuss that how it works. Now let's go to PG admin and let's try to execute this particular code here. Okay, now here you can see on my left hand side I have different databases. I have restored the university database already. If you have not done that, please restore this database, because all the code that we have discussed in the lecture is based on this particular database university. Okay, so if I want to use this university database, simply right click on that and go to query tool. So what we have discussed, if I want to get a name of all the instructors, that is what select name from instructor, right? In this way I am going to get all the name of the instructor from the instructor table. So you can see we have 50 rows and 50 names are there. So this was a simple select from a table name, simple select from query. Okay, now if I want to find out the department name in this instructor, so what we can do, select department underscore name from department. So now let's see the output for this particular code. So here you can see civil engineering, biology, history, physics, marketing, English. So total 20 rows are there, right? So here you can see department name is primary key. So all the 20 department are unique here. But now let's try to see a data from the instructor table. So let's see. So if you observe, we have 50 rows in the instructor table. So here we got a duplicate as well, right? If you see, if you just scroll down, you can see biology getting repeated here, mechanical engineering getting repeated here, right? So we don't have a 50 department name. These are the repetitions are present here, right? But if I want to find out distinct department name in the instructor table, what you can say, just use a distinct keyword here. Select distinct, that particular column for which you want a distinct data, you have to specify like this, and from which table, like for example for instructor, from instructor, right? So simply execute this one. So you can see 17 rows now. So here you can see we have a 17 department in the instructor table. In the department table we have 20 different department, but for 3 departments we don't have a data for the instructors, right? So this is what I can say. So this is how this distinct keyword will work. Okay, now let's go to a slides and discuss it further. Now here you can see a select a thing here. Again, select star from instructor. What does asterisk symbol means? It means all the attribute. If I specify select star from instructor, so I'm going to get the data of instructor table, all the columns, all the rows. Okay, now here you can see an attribute can be a literal with no from clause. If I simply say select 437, so it is giving me the output 437. Or for example, if I say select 437 as FOO, so what is going to happen? FOO as my column name and 437 as the data. Okay, this is what this query will run. An attribute can be literal with from clause. So when I say select A from instructor, so what I am going to get? I am going to get the output A, but n number of times, for which we have the rows in the instructor for n rows, the number of tuple in the instructor table. Okay, now let's try to discuss this in the PG admin. Now here you can see select name from instructor. Now if I simply remove this name and put star, what happens? Select star from instructor, right? So here you can see all the four columns are present with all the data. So if I want to view a data from any table, simply use this particular code. Select star from instructor. That's it, right? So all the four rows and all the columns we are going to get with this particular query. Now if I say I just want ID and salary, I don't want name and department, so you need to specify like that, ID comma salary here. That's it. If I simply select this, I am going to get ID and salary here. Okay, so here you can see. So this is about the select clause here. Also, if you simply say select, then I have this 437, right? If I simply select this, I'm going to get this as output as 437. Same as print statement in Python, right? Also, if I say 437 as F double O. So if you observe here, we don't have a column name. But if I give as F double O, so this will be a column name in the output. So here you can see F double O 437. Okay. So this is what this select clause will do. Now let's go back to our slides and let's discuss it further. And now if you observe here, we can also perform some arithmetic operations inside the select clause. For example, you can see inside this query, select ID, name, salary divided by 12. Okay. So you can see from the instructor table, we are dividing the salary by 12. So here we are performing a division. So we can perform addition, subtraction and multiplication inside the select clause as well. So we'll try to execute this particular query and let's see the output. And here you can see we can also rename this as a monthly salary. So if you observe in the instructor table, salary is basically a yearly salary. If I divide it by 12, that will be a monthly salary. But if you observe, the column heading will be different. In this scenario, it is at by default. But here if I want to give a custom name to that particular column, I can give here, for example, monthly underscore salary. Okay, now let's try to execute this to query inside the pgadmin. Now first let me remove this part. Now here ID, and we have a name and then we have a salary. Okay, so first let's discuss. So first let's see the data here, salary, right? So here you can see a data of an instructor table, 50 rows, ID, name and salary. Now if I want monthly salary, what I can do, simply divide by 12. So if I divide it by 12, now see what will happen. So here you can see that is basically what? A monthly salary here. But if you observe column name, right, question, we don't have a specific column name for this particular attribute. For that purpose, we can use the alias or rename operation as monthly salary. You can give any name here, for example, monthly salary. Okay. Now, if I run this, now if you observe here, instead of column, that will be a monthly salary. Let's try to do that. Yes, so here you can see monthly salary. But remember this, whatever the rename we have done this, it is only for this particular output, not in the original table. In the original table, it is still as a salary. This is only for this particular output of this SQL query. Okay, let's remember this point. So this is how we can perform the arithmetic operations in the select clause. So addition, subtraction, multiplication and division you can do according to the requirement. Now next we have where clause. So as of now we have just simply discussed select from. Select some column from this particular table. But what if I want to put some condition here? For example, if I simply select this particular thing, select name from instructors, I am going to get the name of all the instructors in the instructor table. But the moment if I put where clause, where department underscore name equals to computer science, I am only going to get the name of all the instructors in the computer science department. Okay. Now let's try to execute this particular thing. Also, I can put multiple condition by using this logical connectives called and or not. Right. For example, select name from instructors where department is computer science, but also I want those instructors whose salary is greater than 80,000. For those, for that purpose, we need to use these particular conditions. Okay. Now let's try to execute this particular query. Now here you can see select We can say name or salary from instructor. So here in this case, I will get all the data because I have not applied anywhere condition here. Now the moment I will put here where department underscore name equals to computer science. So remember in the data we have com dot, then we have science dot. This is what computer science is, okay? And whatever you put inside this particular quotation, that is basically a case sensitive. So be careful while putting the condition inside the single quotation here, okay? So if I simply select this, so here I can see I have two instructors from department computer science, okay? So this is the output of SQL query. Now also I can put multiple condition by using and or or. So if I put and here and one more condition that salary, it should be greater than 80,000, right? Now let's see the output. Not 80,000, let's say 81,000, because if you see I will get the same data. Now here if I say 81,000, it means that I'm going to get only one output, that is 1D and this particular salary, okay? So if I select this and execute, so this is the output what we got, okay? And here if you observe, department equals to computer science and salary greater than 81,000. If I simply change this to OR, what happens in the case of OR and? See here, and means what? Both the condition must satisfy, then only you will get the output, okay? So according to this particular condition, both the condition we are getting this output. The moment I will change this to OR, now what is going to happen? Department name equals to computer science or salary greater than 81,000. It means that I am going to get the name and salary of instructors where department equals to computer science or the instructors whose salary is greater than 81,000. Okay, so both the conditions here. So here you can see we have 25 such things. If you observe, other instructors are not from computer science department, but their salary is greater than 81,000. Okay, so this is how we can use multiple condition inside the where clause. I hope you understand this particular concept. Now we have discussed this where clause, and now here we have from clause. And here you can see select star from instructors comma teachers. So as of now we have only dealing with, so as of now we are only dealing with the one table, that is instructor, or any one table. Say for example department, select star from instructor. But here we can say comma teachers. Now what does this mean? Okay, select star from instructor comma teachers. So when we use this particular thing here, table 1 comma table 2. So this is table 1 and this is my table 2, right? It means we are performing a Cartesian product between these two tables. So here you can see the output. So this instructor table, this teachers table, okay? And we are performing a cross product by simply mentioning teachers comma instructor comma teachers. For example, if we have 10 rows in this instructor table and let's say 5 rows in teachers table, so if I just simply perform select star from instructor comma teachers, so by Cartesian product in the output it will have 50 rows. 10 into 5, that is 50 rows, okay? So we are going to discuss this thing in detail in the next lecture, that is lecture 2.4. Okay, I hope you understand what we have discussed in this lecture 2.3. All the code we have discussed in detail, and for data types and constraint I will suggest you to watch the tutorial next. Okay, so that's it from this particular video. Thank you.